So, good day everyone. My name is Denmark Lunop and together with Mr. Alabat, we're going to talk about order and inequalities and at the same time, absolute value. So, without any further ado, let's start. So, by definition, for any real numbers a and b, if a is less than b, means b minus a is a positive number. So, to understand that, we're going to have an example. So if you look here, A is equals to 7 and B is equals to 9. So if you um, subtract 7 to 9, the the answer is 2, which is a positive number. So this definition is true for any real numbers A and B as long as A is less than B. So geometrically, if A is less than B, if A lies to the left of B on the real line. So let's take a look at here. So if A lies left to B, that means A is less than B because it lies left on the number line or the negative number. At the same time, on the positive side or in the right side, that is the higher number or the higher the zero number. So that's all. So in proposition 1, if A and B are both positive, then A plus B and A times B are positive. So if you have a number A and B which is both positive, if you add that number, the answer will be equal to a positive number, always a positive number. The same case when multiplying the two number. So if you multiply A and B, which is both positive number, the answer will always be a positive number. And that is for our proposition number 1. So in proposition number 2, for any real number A, so either A is a positive or A is equals to 0 or A is or negative A is a positive because if you negate negative A, it will equal to a positive number. So that's all for the definition of order. So these are the common inequality notation. A is more than B means B is less than A. So the other one is A is less than or equal to B means either A is less than B or A is equal to V. So that is very easy to understand. So moving on, if A is more than or equal to B means B is less than or equal to A. So that is the reciprocate or of this one. So having an example, so example number 1, 2 is less than 5 because 2 lies left on the number line compared to 5. So that means 2 is less than 5. So this one, negative 6 and negative 3. So if you notice, negative 6 lies left on the number line compared to the number negative 3. So, which means negative 3 is higher or more than negative 6. So, this one, 4 is less than or equal to 4. So, it is true that 4 is equals to 4. So, this one, 5 is more than negative 8 and 6 is more than or equal to 0. Although 6 is not equal to 0, but it is more than 0. So it satisfies the notation. So this one, negative 7 is less than or equal to 0. So because 7 lies left on the number line compared to 0, meaning negative 7 is less than 0. So let's try to sort the number 4, negative 7, 9, negative 2, 6, 0, negative 11, 13, negative 1, and negative 5 in increasing order. So meaning, we need to find the smallest number up to the highest number. So if you notice, we have here negative 11 as our smallest number because is it lies to the left of all the numbers here. It's on the left of all the number here, so we're going to put that on um, the lowest um, order. So negative 11, negative 7, negative 5, negative 2, negative 1, 0, 3, 4, 6, 9, and 13. So that's your going how these numbers um, lies in the number line. So let's also talk about this one. A real number is a positive number if and only if a is more than 0. So again, if the number lies on the right side of 0, meaning it's a positive number. So if a is more than 0 or on the right side of 0, meaning it is a positive number. At the same time, a is a negative number if and only if a is less than 0. So meaning a is on the left side of the number line or here, which is a negative number. So that's all. That's for that part. Let's continue. So, going on to the next proposition, let A, B, and C a real number, then A is less than or equal to A. So, that's very easy to understand. So, second one is if A is less than B or equal to B, and B is less than or equal to A, then A and B are an equal number. So, number 3 is if A is less than or equal to B and B is less than or equal to C, therefore A is less than or equal to C because this one bridges A and C. So, B bridges A and C. So, that is very easy to understand. Let's move on to law of dichotomy. So, for any real numbers A and B, exactly one of the following holds. Whether A is less than to B, A is equals to B, A or is more than B. So, for any number, if you think two number, so this, it holds the following. It holds the following properties, whether A is less than B, A is equals to B, or A is more than B. So, for example, the number 1 and 2. So, which one? That one. So, for any real number, one of that law holds. I'm sorry for that. My phone just fell. So, proposition 2.3, let A, B, C a real number such that A is less than or equals to B, then A plus C is less than or equals to B and C. So, let's have an example here. So, when A is equals to 2, B is equals to 3, and C is equals to 4, so therefore, 2 plus 4 is 6 and 3 plus 4 is 7. It satisfies that if A is less than B, therefore, A plus C is less than B plus C. So, that is true for any real number. So, next is A times C is less than B times C when C is more than 0. So let's also have an example here. So when you look at the example, so 2 times 2 is equals to 4. And that is less than 3 times 2, which is equals to 6. And that satisfies the law of trichotomy as long as C is more than 0. So let's try Z that is less than 0. What will be the result? So let's take a look on here. So our C is less than 0, which is negative 2. If you multiply 2 into negative 2, the answer will be negative 4, and this will become negative 6, and in this case negative 6 is less than negative 4. So that satisfies the law of trichotomy. This one. When C is less than 0, meaning A times C is more than or equals to B times C. So I think that's all from my part. And we're going to have Jomar Alabat for the absolute value. Thank you.
So good day everyone. To continue the discussion of our report, so let's continue on absolute value. So absolute value, the absolute value of the real number E is denoted by absolute value of E and represent its distance from 0. So this is the rules of absolute number. If E is greater than or equal to 0, then E is equal to E is E is E is greater than or equal to 0. Then 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 E the absolute value of E is equal to E itself. So the absolute value values the number itself. So number 2, the rules. If E is less than 0, E is less than to 0, then absolute E is negative E is equal to negative E. The absolute value of the is the opposite of the number. So example, I'm not include the example in here, but kay nakuyangan man. Example, absolute value of 5 is equal to the absolute value of 5 is equal to 5 because 5 is greater than or equal to 0. So second example, if negative, then the absolute value of negative 5 is the equal to 5 because negative 5 is less than to 0 and the opposite of negative 5 is 5. So remember ani mo ra ni answer diri kay always positive. So mura. So this time formula. So the distance between two real numbers E and B is denoted by D and EB is equal to absolute value of E minus B equal to absolute value of B equal to E. So the distance between the real numbers E and B is given by the formula of D. Taglaw na ko ini gay na. So this formula use the absolute value to calculate the distance. It doesn't matter which number you subtract from the other. The absolute value ensures that result is always positive. That was I said earlier that anija kanang answer is always positive. So example, the distance between 2 and 7. So using this formula we can define what is the distance between them. So absolute value of 2 minus 7 equal to absolute value of negative 5 kay minus 1. So dako man ang minus negative siya. So equal to 5. Amo na yung 5 na answer kay always man positive. So a negative 5, an absolute of negative 5 is hanapon ni man opposite ninja. So may opposite di positive 5. Ano na. So second example, the distance between 7 and 2. Oh, 7 na to is absolute value of 7 minus 2 equal to absolute 5. So equal to 5. Kay 5 naman sa amay ng positive. As sa first example naman to negative. So summary, the absolute value of provides a way to represent the magnitude of a number without considering its positive or negative. The distance formula liberates the absolute value. To calculate the distance between two numbers, and the number is resulting in a positive. Always remember that always positive ang answer. Value represent the distance between them. Kung makuha ni mo, nanay, pag kuha ka ng distance, nanay mo, gamiton. So, properties of absolute value. So, here the properties of absolute value. So this is the 5 properties of absolute value. So, assuming A and B is a real number. So, this is number 1. Proposition of 2.4, let A and B the any real numbers. So 1, non-negative. So, absolute value of A greater than or equal to 0, and absolute value E is equal to 0. So, the absolute value of any is always greater than or equal to 0. So, absolute value of E is equal to 0 only if E is equal to 0. The absolute value is 0 only if the number itself is 0. So, number 2. So, bounds. Negative absolute value of A is less than or equal to A or less than to equal to absolute value of A. The number A is always bounded by negative and positive absolute value. So, number 3. Multiplicative property. So, absolute value of AB is equal to absolute value of A and absolute value of B. The absolute value of the product is the product of the absolute values. So, magbalik-balik na. So, triangle of inequality. Absolute value of A plus B is less than or equal to absolute value of E plus absolute value of B. So, the absolute value of a sum is less than or equal to the sum of the absolute value. This is crucial inequality with many applications. So, reverse triangle. Absolute value of E minus absolute value of B is less than or equal to absolute value of E plus B. The absolute value difference of two absolute value is less than or equal to absolute value of their sum. This related to triangle inequality. So, okay. So, tackle to definition of intervals. So, definition of intervals. This section defines the mathematical intervals. So, an interval A and B represent a set of real number between E and B. Nagihan naman sab nato ini. So, this is the different types of intervals. Open. Pag open ganay ka ng murag straight ra long ra balik ra. Call open inanan open o E and B. Open interval E and B. So, closed. Pag close ingana ra half open. So, good day. Sorry to cut the video earlier. So, we have now on graphical representation of interval. So, visualizing interval on the real number line. So, there are two visualize on the interval. So, this open and close. When we say open interval represent using parentheses. Graphically, open interval are shown with hollow circles or open dots at the endpoints E and B, indicating that their endpoints are not included in the interval. So, nadura pag kabay naman kapag open na interval. Tamang taglaw na ako earlier. So close intervals. So close interval represent using square brackets lang dari kanang tapakita gani ako ganun pina-square siya na brackets. So amo aton open interval. So graphically, close interval are shown with filled orders and the closed dots at the endpoints E and B, indicating that T are endpoint and including to the interval. So amo na to open sa non-closed, amo ton parenthesis na open sa non-closed na interval. Then tag-tackle natin gapon. So we have now on example of interval notation. So example of interval notation. So convert inequalities into interval notation. So these sections demonstrate how to convert inequalities into interval notation. The examples show how to express the solution sets of inequality using interval notation. Remember that kanang greater than or equal and less than or equal are indicate close endpoint square brackets, and open and less and more than indicate open endpoints parenthesis. So example 1.2. So 1.2 is greater than or equal to x 1.2 is less than or greater than x, and negative 5 is less than or equal to 8. Then kanang umay ning araw. So in interval notation, this is 713. So amo na ni kanang gi plus ra ang 2 sa ng 5 o ang 5 sa ng 8 gi plus nara. Example 2, negative 1 is less than to or equal to x plus 3 or less than to equal to 4. So amo daw negative 4 kay when we say pakuan plus sign man sa number 3 gi-add man na, then amo daw 4. So close interval gyapon ini sa nan 3 sa nan gi minus ran 1 sa nan 4. So example number 3. So negative 6 is less than or equal to 3x or less than or equal to 12. Solving these inequalities gives negative 2 is less than or equal to x, then or less than or equal to 4 in interval notation. This is negative 2 and 4. So we have now an infinite interval. Infinite intervals. Interval extending to infinity. So this is the interval that extend to infinity. Recall that infinity is signs like pinahigdan 8. It's not a number, it represents a concept of unbounded that notation uses parentheses like and to denote exclusion of the endpoints and square brackets and the denotes of inclusion. So negative open intervals negative 8 represent that represent all real number less than a. Note that negative infinity is always and open endpoints. So dere negative infinity and a. So open sa non-closed interval. So this represents all real numbers less than or equal to a. Mana to less than or equal. Diyaw no makita masab dira sa PPT. This page na makita bansab na on less than to a. So number 3. Open intervals in A and infinity is equal to parenthesis. Okay. So this represents all real numbers greater than a positive infinity is always an open endpoints. Oh, kana. I give a feedback if mahumanining kon report. So number 4 na ta. So a and infinity, this represents all real numbers greater than or equal to a. Muna na. Murad to sa infinite intervals. So let's on density of rational numbers. So this section discuss the fundamental property of a rational numbers. So theorem 1, rational numbers are dense. So explanation. This means that between any two distinct real numbers, no matter how they are, you can always find a rational number. Rational numbers are numbers that can be expressed as the ratio of two integers. So real numbers or including rational numbers are irrational numbers like pi na mga square root of 2. The density of rational numbers is significant to really analysis. So this may taglawang gaina. So it is since that image explain how to represent enter by extending infinity and introducing the importance of mathematical property. So that's all to our report. Thank you for listening, and I hope you have learned in our report. So this is the reference of our reports. That's all. Thank you.